Hello, today we're gonna cover the three laws of motion. So let's get on with this. The first law says the following: every object will remain at rest or traveling at a constant velocity unless an unbalanced force acts on it. So basically, let's say we have a car and the car is at rest. So the car is traveling at 0 meters per second. So basically at rest. If there's no other action, there's no force that is acting on it, the car is not gonna move. Um but let's say we have Bob here, okay? And Bob is trying to push the car because he's a messer. Then what happens is that Bob is applying a force, let's say for example 80 newtons. Then what happens is that the car is going to move because there's an external force acting on it. So that's basically it. We're just assuming that there's no friction, there's no air friction at all, or there's no gravity, okay? So there's not any kind of force, because any friction or gravity is a force, okay? So we're just assuming that there's no force, there's no external forces, but the one we're talking about. So let's say in this case, Bob. But for example, what happens if we have a ball? This is Bob's tennis ball, and it's in the outer space. Okay, and the ball is traveling at 2 meters per second square. Not per second, excuse me. Well, the ball is gonna keep moving until there's some kind of force that's gonna act on it. So imagine there's no force that's acting on it, and it's just moving. It's gonna keep moving at the same speed, all the time. So it's gonna keep moving on and on and on. But what happens if it, after a few years of traveling, it meets with Bob's second ball, okay, and they collide? Well, then the ball is gonna bounce off somewhere, and this one is gonna bounce off somewhere else, and their speeds are gonna be reduced, or they're gonna remain at rest. Depends on the velocity and other factors we can't really get into now, okay? So let's go into second law, okay? This is a bit more tricky. It says the following: when an external force acts on a body, the rate of change of the body's momentum is directly proportional to that force and takes place in the direction of that force. So if we find the logic of it, we're going to see that it's actually not that difficult. So let's say we have a ball, okay? And the ball has the same mass, okay? And the first time, we're going to apply 10 times more force than the second time, as you can see here, okay? So the formula you've seen before is F is equal to ma. If we apply a force of 40 newtons and the mass is 8 kilograms, the acceleration that little ball is gonna experience is gonna be 5 meters per second square. Okay, so as the acceleration is gonna it is going to experience. But let's say we applied 40 times less force. Let's say we applied 4 newtons. So we apply 4 newtons. The acceleration this body is gonna experience is gonna be 0.5 meters per second square. So as we said before, here we applied 10 times more force than here. So what it means is, as you can see, the acceleration is going to be 10 times greater when we apply 10 times more force than in the other case. So as you can see, this is proven. So when an external force acts on a body, the rate of change of the body's momentum is directly proportional to that force, which we just proved, and takes place in the direction of that force. That little part there means that if we apply a force of the ball into this direction, into this direction here, the ball is going to keep going on into the direction of that force. The ball isn't going to bounce up or down or any other direction. The ball is going to keep moving into that direction, okay? So that's what it means when you see it takes place in the direction of that force. So that's basically what it means, okay? So now we'll find the logic of it. It'll be a lot easier to understand the definition. And now let's get to the third one. You might have seen another description for this, but this is the easiest one, I believe, which is every action has an equal but opposite reaction. So basically, let's say we have Bob again, okay? Bob is a messer. The teacher told him not to get on top of the chair, but he did anyway. So he's exerting a force down of 800 newtons, let's just say. Well, that's the action, okay? That's Bob's action. He's just on top, or he's sitting on a chair, or anywhere. He's exerting a force of 800 newtons. But every force has an equal but opposite reaction, which means that the chair is exerting a force of 800 newtons in the opposite direction, okay? So them two cancel each other out, and there's no movement, and there's no speed or acceleration. That's what it means. If the chair wasn't exerting this force, let's say the chair could only support 600 newtons, well, the velocity would be different, okay? The velocity wouldn't be zero, which means that the chair will break and Bob will fall off. And same applies here to any kind of example. If Bob is trying to exert a force of 600 newtons here, let's just say, to this wall, the wall, unless it's a really light or not really, let's just say the wall is really heavy and he's not able to move it, the wall is exerting another force of 600 newtons in the opposite direction. Because if it wasn't that case, then Bob would be moving the wall. So that's basically it. The three different laws, and they all really make sense if you try to find the logic of it. So before you learn it by heart, I think you should try to do a few exercises online and see if you can find the logic of it, so it'll be easier for you to understand. I'm going to upload this sheet onto Dropbox, and I'm going to put the link into the description so you can see it and you can work on it, okay? So thank you for watching.